Welcome to Brain Vision.
So we are to use the periodic table to determine each quantity. That is the number of, the first one here is number of 2s electrons in lithium. So lithium is in group 1, and that is period 2, and it is in the S block. So being in the S block and in group 1, that means it's going to have 2s1 electron. So this is S block, period 2, group 1. Make sense? That's it. The next one here is number of 3d electron in copper. So copper is the 29th element. So if you would think about it, being the 29th element, so the first element is scandium, and that's gonna have a D1. Titanium we have a D2. Vanadium we have a D3, and so on up till you get to zinc. So copper will expect to have D9, but there is a special case here with copper, because before the 3d orbital you have the 4s orbital, and the 4s is usually filled, and that gets filled from calcium. Calcium is 4s2. Then when you get to scandium, you start to fill D1, D2 up till you get to copper, where it's D9. But when you look at this, if you remember the principle of half-filled and fully filled orbital in terms of their stability, you realize that half-filled and fully filled orbital are more stable. So we have to rearrange the electron in the 4s and the 3d orbital to have a half-filled and fully filled arrangement. Here we only have a fully filled d orbital, and then the d9 orbital has one unpaired electron. So if we have 4s1 and 3d10, this arrangement is more stable than this arrangement. So copper, we have a d10 electron configuration. So the next one here is 4p, the number of 4p electron in bromine. So bromine is in group 7, and it's in what period? Is in period 4. So being in period 4 and group 7 and P block, so that means we're going to have 4P. So period 4, P block, and then group 7. So the group 7, they have the S and the P orbital. So the S orbital, we have 2 electrons already. Then if it's group 7, then 2 electrons in the S orbital already, then we'll be left with 5 electrons in the P orbital. So the P orbital of bromine, we have 5 electrons. Then the last one is the number of electrons in the 4d orbital of zirconium. So the 4d electron in zirconium. So zirconium is a transition element, and it is in period 5. So transition element in period 5. So we have period 5. So that means we're gonna have period 5. So it's the second one. So we'll have 5s2 being filled, and that 5s2 will stop at strontium, and then you'll have D1 and then D2. But this is gonna be 4D1 and then 4d2, and that will give us the configuration for zirconium. But the 4d is lower in energy than the 5s, so you have 4d, so this is going to be 4d2, then 5s2. And of course, the number of d electron in zirconium is 2.